Hello and welcome to our video on tree diagrams. Now you'll recall from previous videos that probability tables or Karnaugh maps, they're also called two-way tables, they work best when you have two events only. Can't work with more than two. Venn diagrams can be used with two or three events. You could use it with more, but that would be difficult because you'd have to draw your four circles all intersecting and it would be hard to see the different intersections. What we're going to look at today is best for two or more events, and they can be shown using a tree diagram. Our first example here, suppose you flip a coin 3 times. Question A says draw a tree diagram to represent the situation, and B is find the probability that you score a head and 2 tails in that order. So when you're drawing your tree diagram, you want to start with your first event option. So this up here, we're going to label the events. And in this example, it's flips of a coin. So on the first flip of the coin, so I'll put a 1 here, a 2 here, and a 3 here. On the first flip, I could get a head or tail. On the second flip, after I get a head, I could get heads or tails. After I get tails, I could get heads or tails. And here again, you might be noticing the pattern now. Tree diagrams are really useful for showing all the possible options as well, if you're trying to find the full sample space and make sure that you haven't missed out any options. At the right hand side here, we can write out what will happen at each option. So if we take this top root, we get heads, heads, and heads. And we usually write it out like that. Second one, heads, heads, tails. Heads, tail, heads. And I filled the rest of the options in for you there. If we were looking for the probability of this event happening, which would be heads, 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 and I might just put the working down here. We need to look at the probability of each branch of the tree occurring. So when we're flipping a coin, it isn't overly exciting because you've got a half chance of scoring a head and a half chance of scoring a tail. So these two options are the only two options that can happen, either a head or a tail, and they need to make sure they add up to 1. After you get a head, you can get another heads or a tail, and these will have the chance of a half happening each, and so will these options down here. And I filled in the options at the third coin flip here as well. So when you're trying to work out the probability of any of these events happening, you need to work out the probability of the first event happening, which is 1/2 in this example, and multiply it by the second event probability and multiply it by the third event. So that's going to equal 1/8, so we can put that in straight away there. Now this is a fairly simple example, you might have worked this out already. Each of these probabilities, because everything is a half, each of them is going to be a half times a half times a half. So they're all going to be 1/8. So I've gone right ahead and filled all those ones in for you there. And a really good check here is that all of these probabilities you end up with should add up to 1. We have 1, 2, 3, 4, 5, 6, 7, 8 times 1/8, which does equal 1. So it's a good check, and you can see if you might have made a mistake somewhere. This list here is all the possible outcomes. So if you're asked for the sample space, you can read it straight off a tree diagram. Now, question A was draw a tree diagram. Done. Question B, find the probability that you score a head and 2 tails in that order. So it's HTT. Look down this list. HTT, there we go, and it's 1/8. So we can read it straight off our tree diagram. Now, if we only have 2 events, say we're flipping a coin twice, we'd only have the first half of the tree diagram, and we can actually rewrite the final column to show conditional probabilities. So I'll fill in the first half for you. And in this final outcome here, what we're actually saying is this is the probability of a head getting heads, flipping heads with the coin, when you've given that you've already scored a head here. So it's head given heads. This one here is tail given head, head given tail, and tail given tail. And these conditional probabilities work out to be, you can use the same method, so it'll be a half times a half, which is a quarter in this example, because remember we've only got the 2 outcomes. And again, like the previous example, they're all going to be 1/4 because they're all a half times a half.